Hi, welcome to Audiobook Academy. This is a self-paced audiobook. There's no need to keep an eye on things. Just pay attention. Thank you for taking the time to listen. This is a book summary of A Short History of Nearly Everything, a journey into the most intriguing and intractable questions that science seeks to answer by Bill Bryson. Why are we here, and how did it all begin? History and science are seamlessly woven together in a short history of nearly everything in order to answer these enormous questions. From the Big Bang to our present day, Bill Bryson takes us on a journey through the history of the universe and how we came to call it home. In many ways, A Short History of Nearly Everything is a journey through the history of scientific discovery despite its departure from his travel writing. Embark on a fascinating journey through the often boring and intimidating world of science with us. This is a book about how it all happened, written with Bryson's trademark wit, a penchant for delving down rabbit holes, exceptional research, and trademark ability to bring content to life. How from nothing, something emerged, and how that something evolved into the vastness of life on Earth and beyond. Even if you're not particularly interested in science, this book might persuade you that there's more to it than memorizing the periodic table and tackling difficult equations. So buckle up, because we're about to take a brief trip from the beginning to the end of the universe. What distinguishes you from others and makes you, well, you? All too often, we go about our daily routines without ever stopping to consider how truly remarkable we are from a scientific standpoint. Humans are a wonderful combination of cells and DNA, but if we shift our focus even further, trillions of atoms come together to make us. Unless we find ourselves in a specific learning environment or afflicted by an illness, we don't usually question how our bodies are put together. Atoms are the fundamental building blocks of matter, including our bodies and the world around us. They are composed of protons, neutrons, and electrons, and they are the fundamental building blocks of matter. Atoms make up everything you see and touch, from the air you breathe to the water in your cup to the chair you're sitting on right now. There is, however, a fascinating aspect to the atom that we haven't yet discussed. They're biodegradable, long-lasting, and easy to come by. According to Bryson, every atom you possess has almost certainly passed through several stars and been part of millions of organisms on its way to becoming you. In other words, Bryson argues that all of us are the reincarnations of various atoms that have passed through many stars and formed many different kinds of organisms. The universe as we know it was created from nothing at all. The recipe for a universe. To begin, there was nothing. It was an incredible event that took place before we arrived. The universe was created out of nothing. To put it simply, there is nothing here that can be conceptualized as a relational concept. Binary something does not make any sense to us. So let's try and understand this. If you can, visualize a minuscule dot surrounded by a colossal number of protons. Isn't the dot surrounded by something? Remember that protons make up only a tiny fraction of an atom's mass. It could be a dot on a piece of paper or just a dot floating around. At this point, the human mind is ill-equipped to comprehend how it all began. Because we don't have a genuine concept of nothing, it's impossible to imagine that the universe's first invisible dot emerged from nothing. It was completely isolated from the rest of the world. That tiny dot contained matter and particles so tightly packed together that, you guessed it, the Big Bang occurred. Even if it wasn't an explosion, something grew out of thin air. After that, presto. We've gained some breathing room. You can't use space to fill in the gaps and the blanks. As it grew, the universe began to take shape. Space arose spontaneously, without any prior void or expanse to fill. It's this nothing that gives rise to the universe. Gravity was created in the first second of the Big Bang, and the universe expanded to 1,000,000 billion miles in about a minute. These elements were followed by helium and lithium. As a result, in the time it takes to boil a soft-boiled egg, 98% of all matter on Earth has been created. It only took a few minutes. The Unfathomable Abyss. Did you know that an astronomer on Earth could pick up the sound of a match being set on the moon? It doesn't follow, however, that they will be able to clearly see it if they pick it up. As a result, we've come to yet another misperception. What comes to mind when you think of the solar system? When we think of planets, we often think of them hanging from strings, or of brightly colored pictures representing each of the 9 planets in our universe. What about that cool page on an atlas, or a museum exhibit? The reality is that these depictions are nothing like what astronomers actually see in their telescopes. Astronomers didn't discover Pluto's moon until 1978, when they spotted a fuzzy blob. The perfect clarity of artists' renderings has lulled us into a false sense of security about just how far away things really are. For example, it would take us 7 hours to travel to Pluto using a rocket and a GPS. It is, however, based on the assumption that we're traveling at a speed of 300,000 kilometers per second. A decade-long one-way trip is possible with current technology and optimal planetary alignment. According to the narrator, it's impossible for the solar system's scale or volume to be accurately depicted. Even more importantly, we have no idea how little we know about it. Pluto may appear to be the end of the map, but this is only because we haven't been able to look much further. Our knowledge of what we've seen beyond the orbit of Pluto is based on conjecture. What about the possibility of encountering other species in the cosmos? According to current estimates, the Milky Way could harbor tens of millions of civilizations. When compared to the Milky Way's size, millions is a small number. Regardless, this is a fascinating prospect to mull over. That which such civilizations might observe from the outside is even more fascinating. We've already established that the world is a big place. It's just that our brains aren't able to comprehend just how extensive we're talking. An extraterrestrial civilization could watch the French Revolution unfold right in front of them if they are able to locate us and show an interest in following our every move. This is due to the fact that the average distance between any two of these civilizations is approximately 200 light-years. That other beings could theoretically look back at our history is mind-boggling. It's all in the balance. Attempts to determine the exact size of the planet's surface began around 1735. People became enamored with the Earth and sought to learn everything there was to know about it. There were three men who decided to put their money where their mouths were and wager on understanding the Earth's orbit. The cellist Robert Hooke, the architect Sir Christopher Wren, and the astronomer Edmund Halley got into a bet. It was a simple wager. To entice someone, Wren offered a 40-shilling reward for an explanation of the Earth's orbital curve. Isaac Newton, a Cambridge University professor, was approached by Halley for his advice. Newton's most famous achievement was the result of this interaction. 3 laws of motion and the gravitational force were explicated in Newton's Principia, a notoriously difficult book. Finally, we had a formula for solving the problem of our gravitational position. This incredible accomplishment has made Newton one of the greatest thinkers of all time. We may be able to stand on a round planet without falling off if Newton's laws are finally proven to be correct. One of Newton's most controversial discoveries was his discovery that the Earth is not a sphere. The Earth isn't a perfect sphere because of centrifugal force, it's an ever-changing ellipsoid. Of course, this new information had implications for our current understanding of Earth's dimensions. For all the different scientists who tried their hand at it, Henry Cavendish was the only one who was able to nail it down to a T. Dr. Charles Robert Cavendish was a pioneering scientist who used rigorous, time-tested techniques. In 1797, he worked out that the Earth's mass is 6 billion trillion metric tons after a year of calculations. Modern researchers have only improved on Cavendish's findings by 1%. After determining the Earth's weight, the next logical step was to determine her age. Did you know that before we discovered that the Earth is 4,550 million years old, we invented the television, split the atom, and created instant coffee? You can't get away from chemistry. Chemistry got off to a bumpy start. Because of its tainted reputation and lack of respect from the scientific community, it was frequently associated with alchemy and overshadowed by other disciplines. When Antoine Laurent Lavoisier entered the field in the 18th century, it marked a turning point. Despite the fact that his discoveries were few in number, he did bring a sense of order, logic, and method to the field. Chemistry had a brief pause in the first quarter or so of the 19th century, as technology had to keep up with the progress of ideas. A second reason for chemistry's bad reputation was that it was seen as a subject best left to businessmen. After a few notable institutions began to promote chemistry's study, its popularity skyrocketed. As a result, prominent figures like Davy were brought in. Davy probably would have discovered more than a fifth of the known elements had he not died in 1829. Chemistry had made some progress, but there was a lack of coordination and communication between scholars. There was no universal language for simple formulas, abbreviations, and symbols, and it took a long time to communicate significant breakthroughs. It was only thanks to a Swede named Berzelius that chemical symbols were abbreviated according to their Greek or Latin names. Chemical elements were organized into what is now known as the periodic table by Russian named Mendeleev, who was inspired to do so by the chaos that existed in the field prior to that time. Later, he created the table with horizontal rows known as periods and vertical columns known as groups when he was 35 years old. The periodic table has remained essentially unchanged, except for the addition of new chemical elements, since the introduction of the new elements. By the turn of the 20th century, significant advances had been made in the study of electricity, gases, magnetism, kinetics, and other physical phenomena. Albert Einstein and Edwin Hubble, among others, were among those who benefited from these discoveries. living with the decision we've make 'em. To the best of our knowledge, Earth is the only planet capable of supporting life, and it can be a hostile environment at times. 99.5% of the world is uninhabitable to us because of our migration from the oceans to land some 400 million years ago. This is an estimate from our author, but the point is that being land-based has eliminated many possibilities. Due to the high pressure, the ocean is unsuitable for human habitation. It's taken a lot of ingenuity and a fair amount of trial and error to get to the bottom of the ocean. Umberto Polizzi survived a 1992 dive to a depth of 72 meters without the aid of a breathing apparatus. This was hailed as a major accomplishment, and it serves as a sobering reminder of how frail we all are. When it comes to adaptability, humans aren't exactly what you'd call a species that thrives. The Earth's position in relation to the Sun, on the other hand, makes it prime real estate. The Earth's longevity and human existence would be imperiled if the Sun were much larger. At a distance that keeps the planet from being scorched, but close enough for life to exist, our orbit is ideal. If we were 5% closer or 15% farther away from the Sun, according to calculations, Earth would be uninhabitable. We're also fortunate in that our weather is greatly influenced by the Moon, whose gravitational pull keeps us on course. This place is spectacular to spend time in. That we haven't gone to -50 degrees Celsius is due to the atmosphere. We're protected from UV rays, as well as other particles. The troposphere, stratosphere, mesosphere, and thermosphere are the 4 layers of the atmosphere. Almost all of our weather originates in the troposphere, a layer of air that is rich in oxygen and heat. When it comes to the weather, did you know that meteorology didn't become a recognized scientific discipline until the turn of the 19th century? Until this point, inventors had been struggling to come up with a reliable method of determining temperature. It was in 1717 that Daniel Gabriel Fahrenheit developed a device that could measure freezing at 32 degrees Fahrenheit and boiling at 212 degrees Fahrenheit. He came up with a new method in 1742 that put boiling at 0 degrees Fahrenheit, 0 Celsius. Although this was reversed later, freezing is now 0 and boiling is 100, whereas it was previously. A new field of meteorology was born after temperature was figured out. Others began to look at the oceans as a significant factor in weather patterns and phenomena after Howard identified the different cloud types. The importance of the seemingly insignificant details in life. We've all heard that 99.9% of bacteria can be killed by a product, and that sounds great, right? For all intents and purposes, bacteria don't care about that. A little more investigation is in order. 1 trillion bacteria are using your skin as an all-you-can-eat buffet currently. It doesn't matter what your soap says about them, you can't get away from them. Besides the trillions of bacteria that live on our skin, our bodies are infested with bacteria that have made their way in through our noses, guts, ears, hair, and teeth. All around us, they've got unrestricted access to our bodies. Bacteria are in charge, at least for the time being. This is a story about good versus evil, and it's easy to see them as the bad guys. It's true that bacteria are responsible for removing waste, removing toxins, making water cleaner, sustaining the Earth's fertility, and breaking down our food. Also, they're excellent survivors. Scientists revived anthrax spores in 1997. For the past 80 years, these spores had lain dormant. The problem with bacteria is that they can accidentally spread to unintended locations within the body. It is possible for bacteria that are harmless in the gut to cause havoc if they enter the bloodstream. Bacteria can spread to the wrong parts of our bodies when we get hurt internally. Meningitis, which is caused by throat-dwelling bacteria, is an example of this. Everything is fine while the bacteria is in the throat, but if it enters the bloodstream, it can cause death within 12 hours. Peter Medawar referred to them as a piece of nucleic acid surrounded by bad news. Viruses, on the other hand, are smaller and less complex than bacteria, but they're excellent at reproducing if they find the right host. Viruses come in all shapes and sizes, and they can be both harmless and deadly. Within 4 months of each other, the Spanish flu and smallpox killed an estimated 300 million people each in their respective eras. Some flu viruses are deadly, while others aren't. Some viruses affect people who are considered low risk, i.e., the elderly or the young, and some viruses just vanish. We must be ready for the constant influx of new viruses brought on by globalization and the movement of people. We are what we are because of this. Bryson describes us as mundane miracles in his book. It is said that life is fantastically mundane when seen through the prism of chemical elements, certain elements, nothing you couldn't get at your local pharmacy, like calcium, sulfur, and a light dusting of other very ordinary elements are all that's required. What makes the atoms that make you so unique is the fact that they are you. What we are witnessing here is obviously a miraculous phenomenon. Every species on the planet is interdependent. In his theory of evolution, Charles Darwin asserted that we have evolved as a result of our surroundings. Either we succeed or we fail. Welcome to the world of Darwinian evolution. Humans have thrived and progressed in spite of all the odds. In our study of the interconnectedness of the universe, we begin with the DNA. A fruit fly's DNA contains 60% of our own, and 99.9% of our DNA is shared by all humans. Humans love to extol the virtues of our individuality, but the truth is that we're all more alike than we'd like to admit. If we go back far enough, we're all related to one another. It cannot be said too often, all life is one, Bryson asserts. As far as I know, this is the most profoundly true statement ever made. In the end, in a short history of nearly everything, you'll learn a lot about the world around you. At the same time, it conveys a sense of awe at just how small the Earth truly is. What we already know about the subject is revealed, but also how little we know in the grand scheme of things. You can start your journey of discovery with Bryson's book because of its ability to capture nearly everything in a way that is accessible and relatable. This will be an eye-opener for anyone who has shied away from science and history because they find it boring or intimidating. As Bryson demonstrates, almost anything can be both fascinating and mundane when told in the right way. We are, after all, nothing more than a collection of atoms. As long as you're here, the atoms that make you up will all work together to keep you as the person you are today, he continues. In the long run, they'll abandon you and dismantle your system. In the end, as Bryson says, all life is one. Some will stick together, while others will forge ahead on a different path, perhaps finding other atoms to join with, to create something entirely new. Thank you for listening in Audiobook Academy. Please don't forget to subscribe for more content like this. See you in next audiobook.